welcome. Today we are working on converting measurement of in the metric system, and we're looking at grams, which is weight, and liters, which is volume. And these ones are similar, so I think you'll find that they work the same as what we did on Monday with the distance, and also that they're very similar to each other, so they're kind of an easier combination. So once again, I'd like to remind you that in our place value chart here, these words, milli means thousandths, and so it's the tiny ones, and there's 1,000 difference between a milligram and a gram. And then kilo means 1,000, and this is another distance of 1,000 between a kilogram and a gram. So a gram is your standard, and that is the center of this measurement universe, and the gram is the ones place. And then if you have 1,000 grams, another way to say that is a kilogram. And if you divide 1 gram into 1,000 tiny parts, that's what you're talking about when you say a milligram. It's itty bitty. And just like on Monday, I rewrote the 3 measurements up and down because I don't like sideways so much. And we're going to follow the same steps we followed on Monday. So our first step when we look at converting grams to kilograms or milligrams to grams or any of these measurements back and forth is we look at the size of the measurement. And so we start here with grams and kilograms. And a gram is pretty small, right? So this is the smaller one. And a kilogram is the larger measurement, right? So grams and kilograms. So if we have a small measurement, there's going to be a lot more of them than when we convert it to the bigger measurement. So we have here 357 grams, and that is going to be our larger number. And so over here, it's going to be a smaller number, right? So we did that thinking about what's big and what's small and what's going on with this measurement. Now our second step is to find the distance between the 2 measurements. Well, this one, when we're doing grams, we don't have centimeters and millimeters. We just have milligrams, grams, and kilograms, and there's 1,000 in between on each step. And so in some ways I feel like that's a little easier. Those centimeters just add an extra complication. Okay, so if we're going from grams to kilograms, we know that there's 1,000 in between. There's 1,000 grams in a kilogram, and there's 1,000 milligrams in 1 gram. So this makes our jumps pretty easy to figure out. So in between here and here, there's 1,000. Okay, and so then if we are asking ourselves, this number here, we said this was large and it's going to get smaller. So that means we're going to divide. That means our decimal point is going to move towards the left. So then we have the 357 again. And we know this decimal point exists right here. It's just not written in. And we know if we're dividing, the number is going to get smaller. And then following our powers of 10 rule, we know we're going to move 1, 2, 3 place value spaces to the left, smaller, 1, 2, 3. So our answer is going to be 357 thousandths of a gram. And that makes sense because we knew that this was pretty small and that this is pretty big, so it's going to be a small chunk of a bigger measurement. All right, on to the next problem. Look at the size of the measurement. This time we're going from kilograms, which are large, to grams, which are small. And that means that there's not going to take very many of the kilograms to to equal a lot of the grams. So this number is smaller and this number is going to be larger. Okay, so now we know we're starting with 3 5/10 of a kilogram and it's going to get bigger. So that means we're multiplying. And we can have the 3 5/10 and we can put in our multiplication sign. And that means the decimal point is moving to the right. And now we have to find the distance between the two measurements. So here we start at kilograms and we are moving to grams. And we know the distance in between is 1,000. So then we can just write down 1,000 because 1 kilogram is equal to 1,000 grams. And then we have 1, 2, 3 decimal spaces to move. And we count 1, 2, 3, and we fill in our empties with 0. And then we have 3,500. And we ask ourselves, does that make sense? We had 3.5 kilograms, but 3,500 grams, and that does make sense. Yeah, because it's gonna be a lot more grams to be a kilogram. And those will match up. Okay, next problem. Start by looking at the measurement. This time we're going from milligrams to grams. Milligrams are the smaller measurement, grams are the larger measurement. And that means that this number is large, so this number is going to be smaller. And so we are going to we're going to divide, and we're going to divide by the distance between the two measurements. So 1 milligram, 1 gram is worth 1,000 milligrams. There's a distance of 1,000 there. So we're going to divide by 1,000. And that means we're moving 1, 2, 3 place values to the left because the problem is getting smaller. So we write in our decimal point, the number is getting smaller. And we count 1, 2, 3 decimal points to the left. And our answer is 7 854 grams. So it started out being 7,000 grams and it ended up being 7 grams. And we know the distance is 1,000, so that makes sense. All right. Look at the size of the measurement. We're going from grams to milligrams. Milligrams are smaller. Grams are larger. That means this is going to be a smaller number and this is going to be a larger number. Then that means we're going from smaller to larger, so we'll be multiplying. And that means we're moving the decimal point to the right. Now find the distance between the two measurements. Here's grams and milligrams, and the distance between the two measurements is 1,000. And that tells us 1, 2, 3 decimal point spaces. So we have 2 5/10, and we're going to count 1, 2, 3 spaces and fill those in. And our answer is going to be 2,500. And we know that there's 1,000 in between, so 2 times 1,000 makes sense that we would have 2,000 and something. 2,500 milligrams. All right, back to the beginning. Look at the size of the measurement. Grams to kilograms. This is the smaller one. This is the larger one. That means this is going to be the larger number, and this is going to be the smaller number. That means division. Now we look at the distance between grams and kilograms, and we see it's 1,000. Then we're multiplying or dividing by powers of 10. So here we go. 497 divided by 1,000. Divided means the number's going to get smaller. Smaller means the number's going to the left. Ready? 1, 2, 3. Because we see 1, 2, 3. Here we go. 497 thousandths. Last one, measurements. Milligrams to grams. We should have done to kilograms. Let's change it. Milligrams to kilograms. So this time, milligrams are the smaller number, kilograms are the larger number, and that means our answer is going to be smaller, right? Because this is the bigger one, so this is the smaller one. So now we know we're dividing. And now we have to look at the distance between the two. If we start at milligrams and we jump 1,000 grams to get to, jump 1,000 milligrams to get to grams, and then 1,000 more to get to kilograms, that means we are dividing by 5, 6. We are dividing by 1,000,000. We've got 1, 2, 3, 4, 5, 6, right? 6 zeros. So that means we are removing 6 spaces. 1, 2, 3, 4, 5, 6. So we get our poor little 157 2/10. We're going to count 1, 2, 3, 4, 5, 6. We fill in the zeros. And this number is so small, we don't even have on our place value chart this measurement out. And so it goes tenths, hundredths, thousandths, 10 thousandths, 100 thousandths, millionths, 10 millionths. It looks like it's going to be 10 millionths. So 1,572 10 millionths. My goodness, what a small number. Okay, last one. Also today, we're going to do kiloliters, liters, and milliliters. And we know this means thousandths, and we know this means thousands. So we have the same distance in between 1,000 and 1,000. And I love this because once you understand grams, you understand liters. And once you understand liters, you understand grams. So look at the size of the measurement. We're going from milliliters to kiloliters. So here we are making that double jump just like we did. And the milliliters are the small and the kiloliters are the large. And that means this number is the big number, the larger number, and this number is the smaller number. So we're going to end up dividing. And now we have to look at the distance between, and we have 1,000 and 1,000 more to go. So that is 1,000,000. And then we count 1, 2, 3, 4, 5, 6. 1, 2, 3, 5, 6. So we know our decimal point is here. We're counting 1, 2, 3, 4, 5, 6. And we have another ridiculously tiny number. So we ignore the zeros when we're saying these numbers, and we look at it and we say that is 15,675, and then we count tenths, hundredths, thousandths, 10 thousandths, 100 thousandths, millionths. So it's 15,675 millionths. Wow, it's a big jump. Okay, step 1, look at the size of the measurement. Kiloliters to liters. Ooh, we're back to 1,000. Nice. This is the big one, the larger one. This is the smaller one. That means this number is going to be smaller and this number is going to be bigger. And that means we're multiplying. And now, what's the distance between? It's 1,000. And then we move our decimal point to the right when we get bigger. 1, 2, 3. We fill it in. 3,200 liters. Okay, next problem. Liter, smaller, kiloliter, larger. That means this number here is going to be larger. That means we're going to get smaller over here. And that means division. And then we look at the distance from liter to kiloliter. It's 1,000. So we're dividing by 1,000. That's 1, 2, 3 spaces. The number is going to get smaller because this is the bigger one. This won't be the smaller one. So that means we're moving 1, 2, 3 to the left, and we end up with 6 and 592 thousandths of a kilometer. Next problem. Start with liter and kiloliter. This one's the smaller one. This one's the larger one. Next, that means this number is bigger, and this one's going to be smaller. So we're going to get smaller. We divide, and the distance between liters and kiloliters is 1,000. And we are going to move our decimal point 1, 2, 3 spaces. To get smaller, it needs to go to the left. 1, 2, 3 spaces. So our answer is 875 thousandths. Okay? And last two. We have 3 and 2/10 liters, and we're going to milliliters. So the liter is the bigger number, larger, and the milliliter is the smaller one. So we know that this is going to be the smaller number, and this is going to be the larger number, and that means multiplication. Then we look between liters and kiloliters. It's 1,000, and that's 1, 2, 3 place value spaces. And we're going to take our 3 and 2/10, and we're going to move 1, 2, 3. And we are, I divided. What was I thinking? And so now we're going to multiply. We have 1, 2, 3. And our number is going to be 3,200 milliliters. Right? The larger number. I can check and make sure. Yep, I went the right way. All right. Last problem, we're going from milliliters to liters. Milliliters are smaller, liters are larger. Then so that means we are going to, that means this number is going to be larger, and this number is going to be smaller. So that means we're dividing. I got ahead of myself. Okay, so now what are we dividing by? Milliliters to liters is 1,000. So we're dividing by 1,000. So we take this number, 5,864. We know the decimal point goes at the end. Count 1, 2, 3. 1, 2, 3. And we end up with 5 and 864 thousandths of a liter. And today you are going to work on your workbook pages, and you are going to practice these skills. And I am 100% sure that you are going to do well with this. Remember our 3 steps, and think about in your head whether the measurement is bigger or the measurement is smaller, and then the number next to it is going to be the opposite. If the measurement is bigger, the number will be smaller when you're done converting. If the measurement is smaller, the number next to it will be bigger when you're done converting. All right, you guys, good luck. Get to it. Have a great day.